Hello students, welcome to Concept Clarity Tutorials, and I am Navito here, going to take physics classes for class 10. Okay, today's topic is about practice problem for electricity. So we are going to solve problems 7 to 11 from NCERT textbook directly. Okay, let's proceed. Let us see the problem number 7. Problem number 7 on your screen. So it's supposed to give a table. Where's the table? Come on, where's the table? Oh, here comes the table. And there's a subsequent question to it as well. Draw a graph. Okay. Let us solve this problem. We are here to solve problems, right? So here we have a table. Okay, this is a table given. This big table having 5 values, 5 points on the graph. What it shows? It shows values of electric current flowing. That means it shows value of current I, and it shows how the current changes for each potential. For each potential difference, what is the current flowing? That means for 1.6 volts, 0.5 ampere of current is flowing. For 3.4 volt, 1.0 ampere current is flowing. Likewise, for 0.3, for 0.4, this is 0.4 and this is 0.5. What we have been asked? We are asked to draw a graph of voltage versus current. This you do it as homework. Graph of voltage versus current is a straight line graph that we all clear about. You can take the cross mark paper and draw the graph at home. Okay, it's going to be a straight line. And the next question is about the resistance of the resistor. What is the resistance? We know, we have studied from Ohm's law that voltage is directly proportional to current, right? How do we get the resistance? Resistance we will get from the slope of that graph. And how we will get the slope of the graph? By taking voltage and current. Voltage will be on the y-axis and current will be on the x-axis. So here what we will do? We will take 2 points to determine the slope. We will take 2 points on the y-axis and then take 2 points on the x-axis. On the y-axis we have voltage. So let us identify our 2 points. So we will take this as 1 point and this as the second point. We will call this points as first point, and this point we will call as the fifth point. Basically, we get 2 points from here. From here, we are going to solve the problem now. Step 1 is basically we have taken the 2 points from the table to identify the slope. Current. What is the current for the first point? First point current is 0.5, right? Given here 0.5. And then voltage is 1.6. 0.5 and 1.6 from the first point. Now, second point, point B. Point B is actually the fifth point of the table. So here we have fifth point, current is, oh, what do I do? No. Current is, oh, am I so, oh yeah, okay, I selected this. 4.0 is the current and voltage is 13.2, right? We can see it here. 4.0 is the current and 13.2 is the voltage. So now how to identify the slope? How to get the slope? How do you get the slope? Y points are basically the V, right? V is the Y point. V1 and V5 is the Y point. Okay, we take the Y point and then X point is basically I1 and I5. So let's solve it now. So we have this. Okay, let's solve this now. We have resistance is identified by getting the slope of the graph, which we will get from y-axis, which is V5 minus V1, and then x-axis, which is I5 minus I1. So here we calculate. Okay, we put all the points of V5 and V1, whatever we have identified here, and solve. So we get resistance is equal to approximately 3.31. Now we take the third point. Third point we take 2 and 6.5, 6.7, and then we take the fourth point also, 3 and 10.2. Okay, See the third point. For third point, we'll calculate the resistor, which is 3.35. And for the fourth point, we'll calculate the resistance as well, which will get 3.4. So the resistance in the range of 3.3 to 3.4. So this is what the value of the resistance of the resistor is going to be from the graph. Okay. So now let's clear this. Let's see your second problem in this particular session is going to be problem number 8. Okay, when a 12-volt battery, what is given in the problem? If you have already read the problem, solve it yourself. 12-volt battery is connected to an unknown resistor having a current of 2.5 milliamp. It's asking find the value of resistance. That means voltage is given, current is given. That means apply Ohm's law. It's a very simple problem. Apply Ohm's law. 2 seconds. 1, 2. Apply Ohm's law. You can do it mentally as well. Okay. Apply Ohm's law. R is equal to voltage by current. Here you will get, here voltage is given as 12 volt. Current, remember, very important. You need to convert this. You need to convert this from milliampere to ampere. 2.5 milliampere. 2.5 milliampere. Yeah, sir. What is this? You are going to pronounce it incorrectly. Then what will happen to the students? Sorry. Okay, 2.5 milliampere. You have to convert this into ampere. That is 2.5 into 10 raised to power of minus 3 ampere. This is the conversion. If it was microampere, then it would have been 10 raised to power of minus 6 ampere. Okay. So now we'll directly substitute. We'll get the value of the resistance, which is 4,800 ohms. 4.8 kilo ohms that was. So next problem, which is the third problem in this particular video and the ninth problem from your NCERT textbook. So what is given here? Let's see what is given. This time a battery is given. Battery is given of 9 volts. It is connected in series. And this series combination resistor, these are all the series combination resistors which are given. And it is asking to find current through 12 ohm. This is a very simple problem. If you understand the fundamentals of series connection, combination resistor, which is a series combination resistor, then you'll know that the current flowing through all the resistors is going to be the same, right? So directly get the equivalent resistance divided by the voltage, and then you'll get the, what will you get? You will get the current here, and that would be the current which will flow through 12 ohm as well. So let's solve it. First we find the equivalent resistance of series, which is a summation. Once we do the sum here, then what we do? We get the total, which is 13.4 ohms. After that, we find the current in the circuit using the Ohm's law. This is Ohm's law. Current is equal to voltage by R total. So we take the resistance from here, and put it here. And voltage we already know, it is already given, which is 9 volts. Okay. We put the values and get the current. Current to 12 ohm resistance will be the same current, which is, what is the current? Not current. Current will be 0.6716 ampere is going to be the current. Now what will be the current to 0.2 ohm? Same. It will be the same current to 0.2 ohm, whether it is 0.3 ohm, 0.4 or 0.5, or if you connect another resistance in series, it will be the same current. It will if the problem is stated like I'll connect another unknown resistance in the series combination, what will be the current in the unknown resistance later on? It will be the same current only, isn't it? No, you have to know the value of the resistance. Once you know the value of the resistance, which is the unknown resistance, then you have to sum. You have to sum all the resistance and then divide with the voltage. Okay. I hope you have understood. If you have some doubt, want to clear your doubt, please put in the comment section and I will respond to that. Let's go to the next problem. Let's clear this drawings. Okay, next problem. Problem number 10. How many? What the problem stating? How many 176 ohm resistors in parallel are required to carry 5 ampere on 220 volt line? That means 176 ohm resistors. How many of them we need to connect in parallel so that you will get 5 ampere on the 220 volt line? What we need to do now? Current is already given, right? Current is given 5 ampere and voltage is known. So we can find the equivalent resistance of the circuit, right? And then we can find how many resistors are required of 176. So let's solve it quickly. Just take 2 seconds to solve it yourself, or pause the video and try to solve it yourself. I'll proceed with the problem. Okay, let me proceed. Solve. It's a very simple problem, slightly tricky maybe for some of you. So given data is voltage is equal to 220 volt. Voltage is given here. Current is given 5 ampere. What we do? We find the equivalent resistance first. Equivalent resistance using Ohm's law is 220 divided by 5, which is 44 ohm. This is the equivalent resistance of the circuit. This is the equivalent resistance of the circuit, which will manage to give 5 ampere current in the circuit. We need 5 ampere. Now it is asking how many of 176 you need to connect in parallel, right? And that 176 in parallel will have to give the equivalent resistance of 44. So now we'll use the parallel combination wala formula. What is the parallel combination wala formula? Reciprocal. So we need to identify how many, right? So we can assume n is the count of the resistors. If we assume n is the identical count for the resistors in parallel, then you get R equivalent. Formula you will get R equivalent, you will get R by 9. R equivalent is equal to R by, not 9, by mistake I said 9, N for 9. But this is the count. This is the count. N is the count of resistors. And how did you get this formula? 1 by R equivalent is equal to N times 1 by R, right? That is the formula. So when you reverse this, when you rearrange the formula, you will get R equivalent is equal to R by N. So after this, we solve for N. We rearrange this. We'll put N in the numerator and you'll get R by R equivalent. You will get this formula, R by R equivalent. Then you put the value of R. R is basically given as 176 ohm. 176 ohm is R. This R value is 176 ohm, right? And divide with R equivalent, which is 44 ohms. 44 ohms will give you 4. So you need four counts of 176 ohm resistors in parallel so that you can produce a current of 5 ampere on a 220 volt line. This you're supposed to solve. Imagine Ohm's law has made many electricians' life very easy, isn't it? Okay, let's proceed. Next problem, problem number 11. This is the final problem. Show how you would connect 3 resistors. Let's read the problem and try to solve it yourself first. See how would you connect 3 resistors of each of resistance 6 ohm, so that the combination will give you 9 ohm and 4 ohm, right? Try to solve it yourself. Let's take some 5 seconds. Slightly tricky problem, so we can take 5 to 10 seconds. You must pause this video and try to solve it. This is going to sharpen your skill on the formulas for parallel and series combination. Okay, and little bit of thinking ability here. Okay, so try to solve it yourself. 1, 2, 3, 4, 5. Okay, let me solve it now. So the way to tackle this problem, see what is given. It is said that you need to connect 3 resistors. You need to connect 3 resistors, and each of the resistors is having 6 ohm, right? So what will happen? It is asking you to produce a combination of 9 ohm and 4 ohm. Now, if you take 6 ohm in parallel, 6 ohm will increase the resistance, isn't it? You'll never get 9 and 4 if you just take directly 6 in series. So you have to use a combination of parallel also here. A series combination and then parallel combination will effectively give you 9 and 4. You have to try it out. Okay. So let's tackle this. So let us see how to obtain 9 ohm first. Let's try it out. So what we'll do, we'll take two resistors in series. 6 ohm we'll take in series. So if you take in series, you'll get 12 ohm. 12 ohm is a series, right? And then what we'll do, now we'll take 12 ohm and connect it in parallel with the third resistor of 6 ohm. We'll connect it in parallel with the third resistor of 6 ohm. This is your direct formula here. This is the formula, direct formula. You multiply series combination with the third resistance of 6 ohm. Then you add in the denominator, you add the series with the third resistor. You will get 4 ohm. Array, we got 4 ohm instead of 9. No problem. 4 ohm is also asked, right? So you got 4 ohm. Right? Let's try another combination now. Let us take 6, 6 in parallel first now. If you take 6, 6 in parallel, then what will happen? Use the same direct formula. For parallel combination, you can use this formula directly. Okay, these are two resistors, 6 ohm resistor, and then the denominator you add. The numerator you multiply and the denominator you add. Okay, and then you'll get 3 ohm. Now 3 ohm we can put it in series with 6. You'll get 9 ohm. So you'll get 9 ohm here. You connect it in series. 3 plus 6, you get 9. Right? So we got both our answers. Okay, we got both the expected questions, whatever is been asked, we got the solution. Right? So what we do to get 9 ohm, we take 2 in parallel and 1 in series. We take two in parallel for 9 ohm. कहाँ से आ गया वो arrow? I want a box. Come on, give me a box. Okay, I got a box. 9 ohm. To get 9 ohm, what we did? We took two resistors in series first and then the third in parallel. Right? अरे, I got ulta here. Sorry. My mistake. First we take 2 in parallel. This is parallel, right? We got 9 ohm here, right? 2 in parallel and then 1 in series. Okay. This was the matching wala. And 4 ohm is matching here. For 4 ohm we take 2 in series and 1 in parallel. So these are the problems for today. Try to re-watch the problem and try to solve it again if you're not able to solve even one of these problems. And if you have any questions, put your comments and I will get back to you. Okay. So let us wind up today's session. Thank you. Like, subscribe if you have understood every problem of this particular concept clarity tutorials, and subscribe so that you can watch many other problems coming forward. Bye.